In section 5.4, number 51 says that Allison is preparing her application for college. She will apply to 3 community colleges and has to fill out 5 parts to each of those. All right, so there's 2 decisions to make here. For community colleges, she can choose from any 3, and then there's 5 parts that she has to fill out for each one of those. Then she's going to apply to 3 4-year schools. So now we've got the 4-year schools. There's 3 of those. And there are 6 parts that she has to fill out for those. So what we're going to get here is 3 times 5 times 3 times 6. And I got 270 when I made that multiplication. Number 53 says that in the game of Clue, there are 6 suspects in a murder that was committed in any one of 9 rooms using any one of 6 weapons. So here's the way I'm going to see this. We have to make a decision of who's going to do what, where, with what. So we have 6 suspects, and then we have 9 rooms, and then we have 6 weapons. So if we make that multiplication, that comes out to, I think it's 324. So 324 different scenarios in Clue. Now, number 58 says that an art gallery has 2 paintings by each of 4 artists. So that's 8 paintings altogether. And how many ways can the 8 paintings be displayed in a row if the paintings by the same artist must be adjacent to, next to each other? So let's get started here. We've got 8 paintings. 1, 2, 3, 4, 5, 6, 7, 8. And let me just note here, we have 4 artists and 2 paintings each. And these 2 paintings, each of the artists' 2 paintings have to be together. That means like artist A's 2 paintings could be here, B's could be here, C's could be here, and D's could be here. It just can't have artist A here and then somewhere over here because they have to be adjacent. They have to be next to each other. You know, I can see 2 ways to think about this problem. Here's one way. We have 8 paintings. I could put any one of those 8 paintings right here in the first position. Then I want the artist, whoever painting this is, I want this artist to be right next to it here. So that would mean that there's only one way to do that. Then I've used 2 paintings already. I've already hung 2 paintings, and there's 8 altogether, so there's 6 paintings left. We could put any one of those 6 here, and then because whatever I choose here, this one here, we don't have a choice. It's got to be a match. Now, we've hung 2 paintings, 2 more, so there's 8 minus 4 paintings. There's 4 paintings left. I could use any one of those 4 here, and then I need a match here. Then there's 2 paintings left. I need a match here. So if we make this multiplication, that comes out to 384 ways we can hang those paintings so that the artist's paintings are next to each other. But here's another way that I could think about it. We've got 4 artists. What I could do is I could select an artist here, and I have 4 artists from which to choose here, and 3 artists for this position, 2 for this position, 2 for this position. So if I start making those choices, I could choose any one of 4 artists for the first 2 positions, any one of 3 for the second 2 positions, then 2 for the third 2 positions, and then finally the only artist left for the last 2 positions. Now, once I've chosen an artist for this first position, I have 2 ways to arrange those paintings, right? This artist has 2 paintings. I could put painting A here, painting B here, or B here, and A here. So for that artist, we will have 2 ways to hang those paintings. Same thing for this artist. There's 2 paintings here, so I can arrange those in 2 ways. 2 ways here, and 2 ways here. So what we're going to get here is 8 times 6 times 4 times 2, which also comes out to 384. So there's just 2 ways to think about this problem, at least 2 ways. And in problem 61, it says 3 couples go on a movie date. And how many ways can they be seated in a row of 6 seats so that each couple is seated together? So we've got 1, 2, 3, 4, 5, 6. So really, you know, this problem is just similar to this problem. This time we have artists and paintings, This time we have couples. So again, there are two ways to think about this problem, and if you think about it either this way here or this way here, both ways, you're going to come out to 48 ways of doing this, and I think that's all I'm going to do in this problem. You can figure it out from here, I'm sure.